Welcome to Built, Wired, and Secured, the podcast where we explore how modern buildings are designed, connected, and protected in the real world. I'm Alex Morgan, and in today's episode, we're diving into designing for the unknown tenant, future-proofing shared infrastructure in spec and flexible spaces, why it matters, where projects usually go wrong, and what decision-makers need to understand before problems show up in production. Joining me today is Michael Harrington, an operator who's seen both sides of this problem. Michael, great to have you.
Thanks, Alex. Happy to be here. Let's cut to it. These are the questions I ask when I walk a riser room. What breaks if this goes down? And who takes the risk when tenants show up with surprises? Those questions drive a lot of design and operational choices.
Cold open. A growing tenant moves into a spec suite, installs racks and a mix of power-hungry equipment, and within a week, the backup feeder trips. The building's main power is fine, but the tenant's systems overload a riser circuit that hadn't been expected to carry that load. Tenants lose connectivity, facilities scramble, and turnover that was supposed to be a win becomes a headline expense. This is the exact kind of failure we want to prevent today.
I've seen that scenario a few times. From an operational standpoint, the root is usually an assumption made long before tenant move-in, either about power density, cabling paths, or how shared systems will be metered. Those assumptions feel safe until they don't.
Over the next 10 minutes, we'll unpack a simple decision framework. Identify brittle assumptions, weigh over-provisioning against lease metrics, and put processes in place so a new tenant's tech can be onboarded quickly and safely. By the end, we'll offer concrete thresholds, labeling standards, and low-cost validation tests you can add to your next project plan. Segment 1. Causes. Michael, what are the common design assumptions that create brittle infrastructure in spec builds? Start with power and riser capacity.
There are a handful. First, designers often use conservative average power densities, say 2 to 4 watts per square foot, which is fine for office cubicles, but not for data closets or tenant lab spaces. Second, riser capacity is sized for the base building load, with minimal spare breakers. Third, shared networks and metering are sometimes planned as single points of ownership, with no tenant demarc, which makes capacity upgrades disruptive. The common thread is optimistic assumptions about what tenants will actually bring.
And for cabling and shared services?
Designers sometimes run a single backbone with only a few spare fiber strands, or they assume tenants will use their own managed services and won't need building-provided subnetting or DHCP scopes. That's fine until a tenant wants to run on-premise systems that need public IPs, redundant fibers, or dedicated meter feeds. You can see how a small assumption turns into a tenant outage or a stop work order during install.
Segment 2. Trade-offs. Owners often face two paths: over-provision generously now, or design lean to reduce upfront cost and space waste, and hope tenants tolerate custom retrofits. How should teams evaluate that trade-off?
Start with a risk matrix. Quantify the cost of over-provisioning, capital expense, lost rentable square footage, and longer construction windows, against the cost of reactive fixes, tenant downtime, expedited material costs, and disruption to other occupants. A useful rule of thumb I use: if a retrofit risk could stop lease commencement or cause more than 2 weeks of downtime, bias toward more capacity or modular designs that are easy to expand.
Can you give specific thresholds you recommend? For example, what spare capacity should teams demand in power, conduits, or fiber?
Yes, for power, design at least 25-30% spare capacity at riser and tenant distribution panels and spec suites. For conduits, plan for one additional empty 4-inch pathway per major riser and 30 to 50% spare interduct or raceway count for fiber. For fiber, secure a minimum of 6 strands per riser with 2 fully redundant paths where possible. Those numbers scale with building size and tenant mix. Labs or tech tenants need higher margins, but these thresholds reduce the need for hot work later.
Segment 3. Operational implications. Having capacity is one thing. Onboarding and documentation are another. What operational practices prevent those spare pathways from becoming useless?
Labeling, testing, and playbooks. First, insist on uniform labeling and a single as-built package that includes single-line electrical drawings, conduit maps, fiber strand counts and test results, and access control schematics. Second, acceptance tests. Energize and load feeders at 80% of expected tenant density, and run OTDR or loss tests on fiber so you know spare strands are viable. Third, a tenant onboarding playbook that defines roles, who pulls permits, who isolates feeds, who coordinates security credentials, and a timeline for move-in. From an operational standpoint, those steps make change predictable instead of frantic.
Quick note on metering and billing. Owners often ask whether to centralize metering or provide tenant-level meters. What's your take?
Tenant-level metering is the safer path if you expect varied loads. It gives transparency and avoids disputes. If you centralize, build in segregation and the ability to add sub-meters later without major demolition. In short, plan for tenant visibility, even if it's not initially used.
Expert insight and examples. Michael, tell us 2 real projects. One where modest planning saved weeks of downtime, and one where missed assumptions caused expensive rework.
Example 1. A mixed-use building we managed kept a 30% spare breaker margin and had empty inner duct in every riser. A tenant later needed redundant fiber and a dedicated utility feed for lab equipment. Because of the spares, we installed redundant fiber and a tenant breaker bank in 3 days with no downtime. Move-in proceeded on schedule. Example 2. Another property skimped on riser space to save cost. A single tenant tried to add a small server room and discovered there was no feasible path for additional conduit without cutting finished ceilings. The workaround cost the owner multiple weeks of tenant downtime, expedited purchasing fees, and tenant concessions. Those 2 outcomes tell you everything about how small decisions compound.
Those are powerful examples. Before we wrap, what are the 3 concrete steps listeners should take on their next spec or flexible space project?
1. Build a risk matrix and set objective thresholds. Start with 25-30% spare power and the conduit and fiber counts I mentioned. 2. Require a standardized as-built package with labeling and test results as a condition of turnover. 3. Create a tenant onboarding playbook that assigns responsibilities, timelines, and acceptance tests. Test that playbook with a simulated tenant move before leases begin. Do those 3 and you convert reactive chaos into repeatable process.
Key takeaways. Anticipate variance in tenant needs. Balance over-provisioning against retrofit costs with a clear risk threshold. And operationalize onboarding with labeling, tests, and a playbook. For templates, checklists, and sample thresholds you can apply to your project, visit our show site and download the free toolkit. That wraps up today's episode of Built, Wired, and Secured. We covered designing infrastructure to accommodate unknown tenants and practical steps to avoid downtime and costly retrofits, and hopefully gave you a clearer way to think about how these decisions play out beyond the initial install. Thanks for spending time with us. Michael, thanks for the operational clarity.
Thanks, Alex. Remember, ask early. What breaks if this goes down? That question keeps you honest about resilience.
Until next time, make sure the systems you're responsible for are built to last, wired with intention, and secured for the real world. Built to last, wired with intention, secured for the real world.